Welcome to another Auto Nerds YouTube video. If you don't know by now, we are the only picoscope automotive specialists. And it's all we do here. And I dug this one out of our archives from a few years ago because I thought it might be interesting to you. This is an ignition problem case study. The subject vehicle is a 2001 Windstar with a 3.8. This vehicle has a waste spark ignition system. The diagram looks like this. We always need good diagrams when we're working with lab scopes to be able to get our wire colors and our pinouts. And aside from direct factory subscription access, an all data subscription is going to get you the most information you can have over a wide range of makes and models with your factory diagrams that you can work with. So that is what we use here for all of our pinouts and things for our diagrams. Doesn't get any better than factory information as far as getting the correct pinouts and wire colors, which is what you're going to need. So this ignition system has 3 coils, and each one of these coils has secondary wires that go to companion cylinders, so that they both fire more or less at the same time. And one is going to be on the exhaust stroke and the other one's going to be on the compression stroke. And then 360 degrees later, same coil fires again. This time the companion cylinders have swapped tasks. Now the other one is on the exhaust and the first one is on compression. So that's just basically in a nutshell how that works. And we've got one here that's running really rough on 4 cylinders. And right away we're suspecting an ignition problem. The engine cranking cadence sounds good, so we just jumped right ahead and did that. Let me show you what the coil pack looks like. This is our coil pack and our companion cylinders. And you can pick out your companion cylinders from the firing order pretty simply by stacking the firing order like this. This is a 1, 4, 2, 5, 3, 6 firing order. So we know 1, 5, 4, and 3, 2, and 6 are companion cylinders. And so here's our one coil pack. It is a pack of 3 coils. Coils are not serviced separately. So this is a great way to approach these V6 waste spark ignition systems. We can look at the entire primary system all at once by looking at each primary to each of the coils. So we have 3 primaries, and then we'll get the coil current for all of the coils. We'll be able to validate our primary drive for each of the coils and look at the voltage on the drive side of the coil and be able to analyze what's going on. As far as logistical hookups, there's a couple of different ways to approach it, and every vehicle is going to be different. It all depends really on where's the easiest place to get to the test point you want to get to. So you look at the vehicle, you look at the layout, get the diagrams. If you're not familiar with that particular vehicle, you need to find that test point. You're going to go for the easiest place, obviously. And normally that would be, putting your current clamp for all your coil currents right around the power supply here to the coil pack. That's super simple. Now in this case, that coil pack is behind the plenum under the cowl, and it is terrible. Access is terrible. So in this case, what we did, the PCM sticking out of the firewall there, much easier to get to. What we just did is went in there and probed our 3 primaries at the PCM, because these are PCM driven coils. Your coil negatives go here, your drivers are in your PCM, and your coils are turned on and off here. So we put our 3 primary voltage taps right there, and then we put our current clamp around these 3 wires. So you can see right away we definitely have an issue. We have a coil current here, and you'll see two humps there because this is a multi-strike, what they call multi-strike, and at idle it's going to strike twice and fire each one twice. This is an emission strategy. A lot of Fords do this up to a certain idle level. Again, if we bring out a ruler here, place it here, and this is the same coil firing again on the blue channel, that's going to be 360 degrees. So we were talking about earlier, it's way spark. So this coil fires here, and if we were to imagine this was the 1-5 pair, one of those is going to be up on compression. Let's say the 1 was compression and the 5 was exhaust. 360 degrees later, your 5's compression, your 1's exhaust. We have our RPM calculated for us right here based on our cursor placement. So let's take a few measurements. About 7 amps, which is normal for your first strike on these. But something odd is definitely happening here. So let's take a little closer look at that area, see what we might be dealing with here. Well, these tiny little spikes, we're definitely going to have to zoom in. Let's go take a close look at this one, spread it out quite a bit here so we can see what we're working with. That current is a lot higher. That's 12.6 amps there on that ruler. And let's just see how long it took to get there. Ten millionths of a second, 12 amps. Something's wrong with this picture. Let's compare that to a normally firing event, one of the other coils here. Got about 7 amps there. And it took us over 3.5 milliseconds to get there. This is because of the inductive reactance of the primary windings. This causes this slope and gradual rise in current. So what does that mean for what we're looking at for the other coil? The questionable event is completely different. This primary gets pulled down to about 2.3 volts, and our current slams to over 12 amps in less than 10 microseconds as we measured before. Let's bring out another ruler on a primary event that seems to be working normally. Let's measure our voltage. Basically 0 volts right here. for this one here was like 2.3 volts. So we got a lot of voltage drop, got a lot of current, going really, really fast, peaking out at 12.6 amps in less than 10 microseconds. So what that indicates is we've got a shorted coil. There's no inductive reactance there. That is a dead short. What's interesting is how quickly that PCM reacts to it and shuts it down. It shuts that driver down right away. Let's just measure the primary on time here for this one. Measuring the red channel there. Shut it down instantly. 11 microseconds. That driver shut down. So this is the PCM strategy to protect itself. It's doing a really good job. And your question might be, well, is that PCM driver toast? Well, it's able to move current. So it isn't totally toast, but it would start generating a lot of heat if it ran for any longer than this, and probably go up in smoke almost instantaneously. But the PCM strategy to protect that driver is working. What we do know for sure is that replacing that PCM isn't going to do us any good at all. That's not where the problem is. The problem is in that coil. That coil is shorted. It's time for a new coil pack. Put a new coil pack on it. Car is fixed. It's been fixed for years. So that was definitely a viable fix there. PCM was actually okay. There was no residual damage to that driver that later showed up as a problem. So again, when you're approaching these V6s with this waste spark, this is a great strategy to look at the three primaries and the coil current together. It'll give you a lot of information very, very quickly. I did want to mention though that although this is a very common and useful test and is used quite extensively in the automotive field on these vehicles, you cannot do this test with any currently available picoscope kit as it comes from Pico, because you need 3 attenuators. If we look at these voltages, we're kicking out on these good drivers almost 400 volts, 360 volts, could be 400, could be higher. Depending on the application, you're going to need to use the attenuators, and there isn't a single picoscope kit out there. I don't care how big the kit is you're looking at. It's only got 2 at best for 4 channels, so you don't have enough attenuators to do this. So that's one of the big differences in the Auto Nerds custom kits. We have put additional hardware in there that you're absolutely going to need. Attenuators is one of those things we add in there, so you make sure you got an attenuator for each channel. You can actually do things like this right out of the box. In addition to that, depending on which kit you select, there's other hardware that's been added that is going to be just as useful to you. So there's nothing more frustrating than to get an expensive piece of equipment in a kit form and then go to do something like this and go, hey, I don't have the stuff I need to do this test. What the heck? We don't want that kind of frustration. We don't want you to have that kind of frustration, and we don't want to hear about it on the phone when you call us up either. So that's why we build these kits the way we do, so that you'll have what you need, and you'll also have us on the other end of the phone, the other end of the email, on the forums. You'll have all these different support resources that you can tap into, when you need help with the equipment. And our forums, of course, is filled with professionals from all over the world. It's a great place to network with other technicians and get some technical assistance for something that you might not necessarily be familiar with, get some direction, get some thoughts. Fresh thoughts are always good to change your mind, set you in a new direction, get you to the solution. So that's about it for now. Appreciate you watching, and I hope you got something out of this one. Thank you.